This is a revision video for P4d, longitudinal waves, ultrasound and the uses of ultrasound. If you look closely at a speaker, you can see it moving in and out. This kind of movement creates a sound wave. A sound wave is a series of oscillations or vibrations which travel through the air in the same direction as a speaker movement. Sound wave is an example of a longitudinal wave. In longitudinal waves, the oscillations are parallel in the same direction as the wave movement. This means that drawing a longitudinal wave can be a little complicated. They are usually drawn like the one in the diagram. They are made up from these areas of high density, which are called compressions, and these areas where the waves are a little bit more spread out, called rarefactions. And the energy is transferred in the same direction as the motion of the wave. So if this wave has been created by a speaker, when the speaker moves out, it creates a compression as the air becomes all bunched up, and this is the region of higher pressure here. When it moves back, it then creates a rarefaction where the air is more spread out. This is a region of lower pressure. It's these compressions and rarefactions which make up a longitudinal wave. Like all waves, longitudinal waves have a wavelength and a frequency. The wavelength of a longitudinal wave is the distance between each compression. A wave with a shorter wavelength has compressions that are closer together, and a wave with a longer wavelength has got compressions that are further apart. The frequency is the number of compressions which pass a given point each second. For example, if 20 compressions pass a point in 1 second, then the wave has a frequency of 20 Hz. The particles in a longitudinal wave vibrate side to side. They are closer together at a compression and further apart at a rarefaction. If the frequency of the wave increases, the air particles vibrate more rapidly. If the sound is louder, the particles vibrate with a greater amplitude. For louder sounds, the maximum distance each particle moves from its central position increases. They vibrate further in each direction. So if this is a central position and the particle vibrates side to side from that 0 point, if the sound is louder, then the particle will vibrate a further distance or a greater distance from that central position. The human ear can detect a very wide range of frequencies. Humans can hear sounds with a frequency up to 20,000 Hz. Different animals can hear different ranges of sound frequencies. The frequency of a dog whistle is too high for humans to hear. Dogs can hear at a much higher frequency than humans. Sound waves with frequencies over 20 kHz or 20,000 Hz are called ultrasound. Ultrasound's a sound wave like any other sound, it's just got a high frequency which can't be heard by the human ear. As you get older, you'll lose the ability to hear higher frequency sounds. At about age 20, you've got a range up to 16,000 Hz. By the time you get to 30, that decreases to 13,000 Hz. But it's not just age. Listening to music that is too loud, particularly through headphones, can do permanent damage to your hearing. We mentioned before that dogs can hear frequencies that are too high for the human ear. Another animal which is able to use ultrasound to detect what's around them are bats. They send out bursts of ultrasound and they wait for the reflected sound to get back to them. So they send it out, it bounces off an object and it bounces back to them. And using this method, they can very precisely detect the distance of objects around them. This method is called echolocation. Okay, so we've talked about longitudinal waves, we've talked about ultrasound. What I'd like you to do now is stop the video and see if you can work through these graded questions. Not only is ultrasound very useful to some animals, it's also very useful to us in medical terms. Ultrasound are very high frequency and short wavelength, which means they can travel inside the body. They are useful for a number of body scans, including baby scans, heart scans, kidney and liver scans. In fact, you've probably already had an ultrasound scan, but you were being too small to remember. In fact, you were never even born. Ultrasound can travel inside the body and produce images that are useful for doctors. They are generally used as a non-invasive means of checking that babies are developing properly while still inside their mother, but can also be used for other things. During a baby scan, ultrasound waves are beamed into the body of a patient from a special transmitter. These waves reflect from different layers inside the body of the patient. The waves return at different times depending on the depth of the layer. A computer then processes this information to build up a picture of the inside of the body. This can help doctors to check that babies are developing properly while still inside their mother. Ultrasound scans have advantages over X-ray scans. An ultrasound scan does not damage living cells as some higher energy X-rays can. This makes them suitable for scanning unborn children. X-rays are very penetrating, and this makes it difficult to see any soft tissue on an X-ray photograph. Ultrasound scans can produce much clearer images of soft tissue, such as the liver and the heart. Ultrasound has a number of other medical uses. Special ultrasound scanners can even monitor the blood flow inside your veins. One of the common medical uses of ultrasound is to break up kidney stones. These sometimes form in a patient's kidney. They can block important ducts and be very painful. Ultrasound can break up the kidney stones inside the body, avoiding the need for surgery. Ultrasound is directed at the kidney stone. This makes the stone vibrate at a very high frequency, causing it to break up into pieces that are small enough to pass out of the body in the patient's urine. So there's no need for any surgery. Okay, so that brings an end to this revision video on sound, ultrasound and the uses of ultrasound. What you can do now is stop the video and work through these graded questions.